Good morning, everyone. I am Inada Patil. Today, I am going to seminar on this simulation of grid-connected EV charging station with renewable energy source. Table of contents: Introduction, EV charging station design, control system, simulation and result, advantage, disadvantage, conclusion and reference. Introduction. The present scenario of the worldwide is that global warming is increases day by day. One of the main reason of the global warming is emission of the carbon by conventional vehicle. One of the best solution proposed over a conventional vehicle, that is electrical vehicle. The EV charging is a main and important aspect where charging can be done by two methods, on board and other one is off board charging. EV charging station designs. EV charging station designs are DC bus capacitor, electrical vehicle battery selection, electrical vehicle battery charger unit, and a three-phase converter LCL filter. This diagram shows that EV charging station, and this EV charging station, the supply is taken from grid and it is connected to the transformer and it is stepped down and it connected to the filter inverter and it's given to the battery. This and a selection of the EV charging batteries. S rated equal to K load into N slot into PEV divided by cos pi, where N slot is the amount of charging slot, PEV is the maximum power rate of individual EV, K load is the overload factor of cover the overload transient. According to the grid voltage, DC line voltage is set VDC is less than or equal to V minimum divided by M minimum, where V minimum is a minimum battery voltage, M minimum is a minimum modulation index. The first one is a DC bus capacitor. The size of the DC capacitor determines the stability of the DC bus. EV chargers are connected to DC bus in the same time. The ripple current will be very high. Thus need a DC bus capacitor. The value can be calculated from following equation. C DC equal to S rated divided by V square DC into 2n into T into delta or cos phi divided by delta x is in terms of Faradays. The value of the DC bus capacitors depends upon the time period T of the AC voltage waveform and allowable DC power delta R bus voltage delta x expressed in the percentage. Battery storage system. Electrical vehicle battery selection. The complex charging and discharging characteristics and relative damageable features of battery. The most commonly used EV batteries is a Li-ion battery. Specification to be considered are they are nominal voltage, cutoff voltage, energy or nominal energy, ampere hours capacity, life of battery, specific power energy and specific power and energy density. This diagram shows that electrical vehicle battery selection. In this diagram, it consists of two IGBTs. One IGBT is operated for a buck operation and another IGBT is operated for boost operation. The main application of the buck boost converter is a regulator DC power supplier where both positive and negative polarity outputs are desired with respect to charging or discharging function of EVs in the charging station. The converter output voltage can be also be either higher or lower than the battery voltage depending on the specific situation. This diode is connected across the IGBT, connected by it in IGBT because of our output. Our output is get sinusoidal. This diagram shows that three-phase inverter. This three-phase inverter is this three-phase inverter. It consists of a six IGBTs and 6 IGBT. 3 is operation for positive half cycle and 3 IGBT is operated for negative half cycle. The inverter is connected between the source and battery charging module and is the control is done by inverter control system, which provide and gate pulse trigger switch of inverter, and LCL filter is also connected with inverter as shown in figure. This is LCL filter. This LCL filter is a passive filter is implemented to reduce the harmonics, which causes the disturbance in the line current and a low voltage, which results in an poor power quality and make an impact on a system. LCL filter This LCL filter is connected between the source and inverter. The filter carry out function to filter out current harmonics, which makes an balance between the source and inverter. An LCL filter is a repair for a third order low pass filter, which provided good harmonics and attenuation and small filter size. This diagram shows that third one is the control system. This diagram shows that inverter control. This inverter is utilized to the power exchange between AC grid to DC bus. The control strategy is implemented cascaded control in DQ frame, and a pulse width modulation generated is used give an gate pulse for a switch of inverter, which helps to maintain the DC bus voltage. The cascaded control have an inner current loop and outer voltage loop. The phase lock loop is a synchronization with the grid voltage and control. This is a full phase lock loop, PLL. This PLL is used for input measurement of a three-phase voltage in a PLL, where output signal VD and grid voltage to used in a DQ frame inverter control. This diagram is EV battery charging control. EV battery charging control, it can be EV charging battery controls are controls. The separate control strategy are implemented to the control the charging and discharging of EV batteries. The Simulink module for a battery charger circuit is shown in the figure. Since we consider an onboard DC batteries charger in the EV batteries directly plugged to the charger circuit, plugged circuit. The first one is a constant current strategy. This constant current strategy, this charging scheme helps to eliminate imbalance of the cell and batteries connected in series. In a CC strategy, the battery operates as a constant current source. The converter will operate in a boost mode, that is a discharging process. This one is a constant voltage strategy. The constant voltage chargers maintain nearly the same voltage input to the battery, and the constant voltage charging is usually causes a high initial current to the battery because of greater potential difference between the battery and charger. In CV strategy, the battery chargers under a constant voltage source. The converter will operate in a book mode, that is the charging process. This is a simulation and result. This simulation module of a simulation of EV charging and discharging mode. The grid connected EVs operating both charging and discharging mode. EVs are plugged into a respective slots provided for charging and discharging. This is result. First, DC bus voltage result. It is a distinguish between time and voltage. This is a constant SOC of EV batteries, that is charging mode. It is charging start from 50%. SOC of EV batteries discharging, it graph is decreases. This is the converter side current. This is a three-phase current. Three-phase current, it is a sinusoidal current. This is a DC bus voltages. Advantages: zero carbon emission, reduction of greenhouse gases, eco-friendly consumption of the PCL fuel is zero. Disadvantage: recharging the battery takes time, and EV batteries is durable for 300 kilometers, as it cannot be used for longer distance, as it is a new technology, so cannot be understood by illustrators. It takes more time for battery charging. Conclusion: this conclusion simulation of the grid connected EV charging station with renewable energy, and this is helps to investigation of the EVs. Distributed generator is also um, used and implemented through the model. The result is for a good, it is operating for a good, and its operate charging of EVs is successfully carried out with the result and represented with different batteries. Reference. Thank you.